Okay, so let's look at how we're going to graph this function here. Determine if this parabola opens upward or downward and find the vertex. So looking at that parabola here, what do you say? Opens upward or downward? Upward. How do you know that? Yes, because A, upward, because A equals 1. Okay? Find the vertex. X equals negative B over 2A. All right, just over 2A. That's the very beginning part of the quadratic formula and the denominator. Okay? So we use this. Who can tell me what A, we already know A is 1. What does B equal to? 0, because there's no x. So B is equal to 0 because there's a 0x implied there. So now if we plug that in, x equals negative 0 divided by 2 times 1. What is that going to be? 0. Anytime you divide into 0, you get 0. And by the way, there is no such thing as negative 0, but I just put that in the formula, okay? Now, that's the x coordinate, x equals 0. So if we plug in x equals 0, f of 0 would be 0 squared plus 3. So what's the y coordinate? 3. So the vertex is going to be 0, 3. Create a table of values for this function using the vertex to determine the x values chosen. So we have, here's our x, create a table of values. So x and y, or y equals f of x, right? So one of the values is the vertex, 0, 3. So we could really start with 0, 3, 1, 2, 3. This is our y. Here's our x. So I'm just going to put some points on here, some numbers on the axes, negative 3. And how about 1, 2, negative 3. Okay, so that's helpful because right there is the vertex. Now, when it comes to a quadratic, you're going to see this pattern most often when you have a basic quadratic, which is really the perfect squares. Because when you plug in 1, x equals 1, 1 squared is 1, plus 3 is 4. Does everybody see how I got 4? So the next point, 1, 4, would be here. Well, if this is the vertex, what's the other point going to be on the other side when x equals negative 1? It's also going to be 4 because there's that symmetry. You see what I'm saying? Let's plug in x equals 2. So if we have 2, I'll just write it here, 2 squared plus 3. What's that going to be? 2 squared is 4 plus 3 is 7. 2, 7 is go over 2, 1, 2, up 7. 3, 4, 5, 6, 7. Okay, so I go over to 2, up to 7. Can anyone tell me what they think the answer would be if I used x equals negative 2? It's going to also be a positive 7 because there's that symmetry happening. So I'll just prove it to you. Negative 2 squared plus 3. That's going to be 4 plus 3. That's 7. So we have 1, 2. Over here is negative 2. And you're starting to see that parabola shape emerge, right? With the symmetry. What is the axis of symmetry? Anyone can tell me the axis of symmetry? Wouldn't it be right here? What is the equation of this line right here? The y-axis? X equals 0. X equals 0 is what's cutting the parabola in half. Okay, you kind of see there's no slope here, rise and run, but the pattern will go 1, 1, because 1 squared is 1, over 2, up 4, because 2 squared is 4, over 3, up, what do you think? Over 3 would go up 9, because 3 squared is 9. Okay. One more example here. So for this function, determine if the parabola opens upward or downward. So opens downward. That's because a equals -2. What's the formula for finding the vertex? First you go x equals -b over 2a. So what's a equal? What's b equal? Good. So we have -6 over 2 times -2. So what's that going to be? -6 over -4, which is 3 over -2, or -1.5, right? Now, a cool way to, if you were going to graph that number, you can always change the scale. If I count by 1, skip 2, 2, skip 1, skip 1, 3, skip 1, 4, what's my scale that I'm using on that axis? Yeah, 0.5. So if I go -1, that way 1.5 is halfway in between. I can use one of my lines. Now that's just the x value. How do I find the y value? Once I know the x value for the vertex, how do I find the y value? Yeah, g of -1.5 equals -2 times -1.5 squared minus 6 times -1.5 plus 9. So if I put that in on my calculator, I don't want to do that by hand personally, but be really careful when you put it on your calculator with your signs and your squaring. So I'm going to go -2 times 1.5 squared minus 6 times negative. Oops, I forgot the negative here, you guys. No one stopped me. I don't know how to insert on this calculator, so I'm just going to start over again. Okay, -2 times -1.5 squared minus 6 times -1.5 plus 9. So 27 halves, or what would that be as a decimal? 13.5, right? So the vertex is -1.5 comma 13.5. Now, so I have to get creative on my scale because this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Only goes up to 10, and I need to go to 13.5. Okay, actually, what I'm also going to do right now is I'm going to show you guys on Desmos how to do this, and I'm not going to be able to do that on the calculator. But essentially what you would do to create your table of values, and Desmos will do this for you as well, is you're just like you're going to do on the last problem. You're going to plug in different numbers for x. You know, if you go around -1.5 to -2, -1, you can plug in different values and get different y values to plot the points. But a graphing calculator will be very helpful here as well. And then I will stop the video and show you Desmos.